It's okay.
It's going to be amazing. Yes. It's going to be amazing.
That's probably enough drinks for tonight.
That's so cool. It's going to be amazing. It's going to be amazing.
That's probably enough drinks for tonight.
Yes. That's so cool.
It's okay. It's okay.
Yes. That's so cool.
That's probably enough drinks for tonight.
That's so cool.
It's okay.
Yes. It's going to be amazing.
It's okay.
Yes. That's so cool.
That's probably enough drinks for tonight.
Hello, everyone out there in Internet land. How are you today? And I welcome you to Percona's regular meetup. Today we are meeting, of course, on Postgres. I am so happy to be here with everyone. Thank you for those who could join us. Today we've actually got something a little extra special. We're testing out streaming live on LinkedIn as well. So we are not only on Twitch and YouTube, but also on LinkedIn. So happy to have people come on out. So Rupesh, hello and welcome. So today my guest is Jobin. How are you, Jobin? Uh-oh, I can't hear Jobin. Jobin, I can't hear you. So one of those awesome live stream things. You never know what's going to happen live, do you? So while Jobin's getting that worked out, let me kind of give you the rundown of what we have planned for today. We plan to talk to Jobin a little bit about what's been going on and he's been seeing in the support community, see if there's anything interesting or new there. We're also, going to be talking through some of the what. Oh wow! Now I'm getting an echo. Jobin, yes, I can hear you, but I was hearing myself as well.
Oops. Okay, so I'll mute.
Okay, so just to give everyone, we're going to take some EC2 and RDS instances from install to configured, and so we have some workload running. So Jobin's going to help us out with that. So welcome, Jobin. How are you doing today?
Yeah, I'm good. Doing good. So today my shift is ended and it's 10 p.m. at 10:30 p.m. here. Yeah.
Well, thank you for joining us late in the evening. So this is an after hours version of the meetup for Jobin. So for those of you who are hanging out and it's late where you are, we're glad to see you. So we are picking up a few folks. If anybody's out there in LinkedIn land, I would love to have you wave just to see if it's actually working, because this is the first time I've tried to stream to LinkedIn as well as Twitch and YouTube. But without further ado, so Jobin, what's been going on? Always interested to hear if any interesting, things have been popping up in the support side of things. Any challenging cases that you can share? Everybody loves to hear the more difficult things.
Yeah, in support we daily handle totally different cases, ranging from wrong expectations till completely out of context problems. I say, especially if those people who move from other database systems like Oracle or they carry certain expectations, and because they are familiar with the certain things and they are looking for the same thing across all databases, which may not be the exact thing here, which will be slightly different. And sometimes even the migration might have done with a slightly something slightly missing. Say for example, the data type selections. So the Oracle may have specific data types in Postgres. The selection of data types is very crucial when it comes to performance. Say for example, Oracle has numeric number data type. Postgres has different types of data types for numbers. Say whether it is a 4-byte integer or 8-byte integer, or variable length integer. And many of the migration tools may deal with this in a generic way, and they may select a variable size data type because that is safest. We can store anything there. But
and I think that's an interesting point. Is database design is kind of a lost art. Not many people think about it, especially with a lot of the migration tools. They just kind of think, let's dump and move it somewhere else.
Yeah. In fact, that is the most crucial thing. The ultimate performance of a database it will be decided by the design, the right design. Rest all things, the tuning can work only to certain extent. That is, this is a damage control basically. the tuning.
Right. Yeah. And I think that, if you can start with a good design, you're way ahead of the game.
Yeah.
And so, I've been doing some testing and some looking, and the performance difference when you choose different data types can be quite stark. It's very, very big.
Yeah, it's huge.
So, and thanks for that, Jobin. And one of the things that you might find as we dig into the workload that we have, ready for us here, is some of the data types might not be optimal. So it might be something that we have to fix. I took a load from a database load from what we were running a few weeks ago at AWS reInvent. So I don't really know what state the schema's in, because we allow people to change data types to see what the impact is. So why don't we get right into this? So I have given Jobin access to a couple of boxes, and I'm going to go ahead and I'll share my screen real quick, just so everyone is aware. What we're going to be doing is we're going to be looking at two different boxes here. This one happens to be an EC2 box, and this is fresh as a daisy installation with the default configuration and no changes. Okay, and so this is running a workload that I call the kitchen sink, which has everything potentially that I could throw into it right now, which is it has some analytics queries, it's got some insert subset deletes, it's got some locks, it's got a little bit of everything going on in this one. Same thing, exact same workload is running on RDS. Both of these are running Postgres 13. So these are set up out of the box without any changes. Now, one of the things to realize, if you are going to deploy via RDS does adjust the configuration for you, right? So right off the bat, you're going to get a more optimal configuration for the hardware based on RDS, just because out of the box, they do some magic to say, oh, you've got X amount of memory, we'll adjust these parameters by default. So that's where we are. And so, Jobin, which one would you like to start with?
Yeah, let's look at the RDS. Yeah,
the RDS one. All right. So what's interesting, just to point out of the box, both instances running. And again, this is all the exact same setup with the exact same code, the exact same structures, everything. The EC2 instance is already performing at 1900 queries a second, and the RDS is at 1500. So you wanted to go command line. So what I'm going to do is I'm going to stop sharing my screen and allow you to share yours if you'd like us to kind of follow along. So that way I don't have to drive everything for you.
Yeah. So what we generally do, so let me explain that part. So when customer approaches with the default setup, we gather certain information about the environment. What are the parameters, and did they really modified any of those things? As you mentioned, some of the parameters are well tuned for their environment, especially the memory related parameters for RDS. But that is not correct for some other set of parameters. For example, the disk related parameters. The RDS has a disk system which is EBS volumes, which is more like SSDs. So we need to tell Postgres that we need to treat this disk similar to SSDs, where the sequential access is almost same as random access. So we need to tell Postgres. So those parameters are not modified, and the most completely off parameter in RDS instance is the number of connections. So
okay. So and why is that?
I don't have any clear reasoning behind why RDS gives such a completely off setting by default. So it gives
Is it too high or too low?
too high.
Hmm.
Same. We can check in this environment. Probably it will be running into thousands. In a say 32 CPU machine or 64 core machine, it will be sometimes even 5,000, which anyway the Postgres won't be able to handle. And it's not just not able to handle. The Postgres performance degrades as the number of connection, because there are some pre-allocations in terms of semaphores and things like that, and the locking mechanism complicates, and the snapshot management is directly proportional to the number of connections. So the as we expose with a lot of connections, there could be a lot of idle connections sitting there, and so the general thinking is that the idle connections won't consume the resources, but that's not entirely true. The idle connection can cause a lot of contention in the system. Yeah. So the very first thing which we do for a RDS instances is correct all these basic set of parameters to something reasonable.
Okay.
Yeah. And the RDS things, it's a little complex to set. Say in normal Postgres, we can set the parameters like alter system, SQL command interface is there, but in RDS we need to create a parameter group and change it. That's
Okay.
Yeah.
Okay. So do you want me to open up the parameter groups in the RDS console, or do you want to look at the shell first?
Yeah, so I can demonstrate how we generally analyze the environments.
Okay.
Okay.
There should be a share screen button in the middle if you see it.
Okay. Yeah, let me pull it to the side. Share screen. Is it visible now?
Yeah, it's a black screen.
Oh. I think I have a problem in sharing. Sorry about that.
No problem.
Because this new Linux, it runs Wayland. Yeah, it was working in the Zoom, so I thought it will work everywhere.
Okay. Well, while we're looking at that, if you want to play with that a bit, I'm in PMM, and just to take a look, you mentioned the number of connections. So the maximum number of concurrent connections right now is in RDS is set to 1691. So 1600 connections.
That's so. What is the instance type you have?
This is a 2XL. So eight cores.
Yeah,
32 gigs of memory.
Yeah, for 8 cores, this many concurrent connections is way too high, because in Postgres every connection is a separate process, the background process. This is a number which the system may not be able to handle at all.
So do you think that they did something behind the scenes, maybe, though? Could they have implemented some sort of pooling without telling us?
No. This is at the Postgres level. Yeah, the pooling comes extra.
Yeah. Okay.
So this is the one of the most important thing which we should be modifying in an RDS instance, and generally this will result in very good improvement in terms of the performance and the contention.
Okay.
Yeah, and another parameter which we can see, the planner's estimate of cost for a non-sequential fetch disk page. It's 4 currently.
So where is that? Oh, this one right here. So
Yeah.
where I'm highlighting. Let me zoom in a
this is,
little bit just
yeah,
so
that,
people
that
can take a look.
yeah, this is the actual parameter name is random page cost. It's it, 4 means the sequential access is 4 times costlier than random. The random access is 4 times costlier than sequential access. So which
Okay,
is
so
not,
if I'm going to create a new options group,
yeah,
that those are ones that I would want to address would be the concurrent connections and the planner estimate.
yeah.
Okay.
Okay.
So did you end up trying to get your screen share to work there or no? You couldn't get it.
Yeah, it's not that easy because I may have to reboot the machine.
Oh no! All right. Well, that's the issue that you get with that live streaming, right? So okay. So let's go ahead and I'm gonna create a new parameter group for RDS here. So you can see my fancy pants RDS. Oh. So okay. So I want Postgres 13, right?
Yeah. Yes.
And so I'm not doing a cluster. So I can just name it whatever I want, right?
Yeah.
Okay. We'll call it Jobin's. So your name will be forever linked to this parameter group. All right. So now you said, now what am I looking for from a connection perspective?
Max connections, the first one.
Okay. So max connections. So here is the least, and here's the formula for them to get that. So let's go ahead and we'll edit that parameter. And what do you suggest we set it to for
So
a box
we
8 cores?
say maximum 4 times the number of CPUs, or maybe 8 times, not more than that.
Okay, just to make it easy, let's go ahead and do. We'll just do 80. So that's 10 times. Seem reasonable. All right. So all right. So we'll go ahead and we'll adjust that. What else do we need to find?
Random page cost. Random.
Okay. Random page cost. All right.
Yeah. You can specify as 1.
1. All right.
Yeah.
Okay. And what else do you want to look at?
The checkpoint related things. Checkpoint timeout.
Checkpoint timeout. So what does checkpoint timeout do for those who are watching?
Yeah. So the Postgres periodically does a checkpoint where it will synchronize, flush out all the dirty buffers to disk, synchronize all the data files, and that information will be added into the control file, saying that up to this point the database is protected from a crash. Okay, the recovery, the next, if at all a recovery is required, the next recovery can start from this point onwards. Up to this point, everything is synchronized. Yeah.
Okay. And so what would you want to set that to? Because
in a production system, we generally give half an hour. So this is specified in seconds, so we can specify
so 1800.
1800. Yeah.
So half an hour. What's the default on that?
It's 5 minutes. 300.
Okay.
And
it's weird that they don't put the defaults in there.
Yeah. So there is it's a criteria for selection. Say if there is frequent checkpoints and if crashes are very frequent, then the recovery time will be less. Okay, but in a Postgres like an database, the crashes is something very rare, very rare.
Right. Okay.
Yeah, and and the system should be more tuned towards the performance rather than the crash recovery.
So in this case, what we're doing is we're saying give us more performance, give us more throughput, and then if it crashes, we'll let it take a little longer.
Yes, yes.
Okay. All right. So what else should we be looking at?
The max file size.
Okay, it is
Yes.
2048.
Yeah, it's a 2 GB. So we should increase that to something bigger. In a production system, generally, how much val we should expect to generate in an hour? Maybe say 40 GB.
40.
So,
Wow.
yeah.
Okay. Okay. Well, I'm not going to give 40 exactly. I'm just, I'll just throw 40.
Yeah.
Because it's 40,000, right? Right?
Yeah.
Yes.
Yeah.
Yeah. Yeah. Okay. So let's go ahead and we'll change that. Now, how would we check to see how much wall size we're going to use in an hour? How do we estimate that?
Yeah, so we have we can collect that information using current val LSN number. We can collect. There is a analysis, the clear cut analysis possible. So by
So
collecting
can we get that from within
that,
PMM?
not now. That takes time because say
Oh.
in every hour, especially in the peak hours. So before the peak hours, what was LSN number, and after the peak hours, what is LSN number? So
So you
we
have
can
to just kind of calculate that by hand.
calculate that, yeah, and
Okay.
we can find out how much of value is generated.
Because this has been running for a day now, so there is workload in the past if there's something you wanted to go back and check. So we actually have the capability to take a look deep in the past if we needed to.
Yeah.
Okay. All right. So back to the RDS console. What else should you be looking at changing?
I think this sufficient to get started. Yeah.
What about like shared buffers?
RDS does it almost correctly.
Okay.
1/4 is the what we generally recommend to get started, and RDS calculates that part pretty much decent.
Okay. Worker memory?
Yeah, so the work mem in production systems, that generally depends upon the number of connections. A thumb rule is start with the 32 MB size work mem.
Okay.
And see, this parameter has a side effect. This is the memory allocated per operation. Say if there is a sort operation or join operation in a query, per operation, per statement, per session. So if there are a lot of complex queries running at a time, so every operation will be allocating this much of memory. So if there is a lot of concurrency, that this can consume a lot of memory altogether.
Okay.
Yeah.
Okay.
So
And
yeah,
so
start
you
with
think
the
that's
32.
it? Oh, so
And we recommend to adjust this value, the work mem, at a lesser scope level. Say if there is a query which requires a lot of complex sort operation, we can set at the transaction level or a session level. So only that query can allocate more memory. See, when we set it at a global level, what happens is it will be applicable for all the sessions.
okay.
Yeah.
Okay. So that's gonna. What
Yeah.
would you recommend?
Yeah.
So just at 32 gig or 32 megs
Yeah.
right now, and just leave it at that. Okay.
Yeah.
Okay. Anything with auto vacuum we should be working or focused on?
So auto vacuum defaults are very gentle. As a maximum 3 workers are allowed.
Okay.
And the
Is
cost
it
will.
by default? Is auto vacuum on?
It should be on.
Okay, because I thought that it was the parameter wasn't set in default Postgres, so maybe that's just maybe I'm wrong.
Yeah.
Okay, but that's it, huh? So
Yeah.
all right, And so for that, so now we've got our parameter groups with Jobins. So now I would go over to RDS. I would find my Postgres RDS. I probably should stop the workload. What do you think? Should I stop the workload before we rebounce it? That would probably be helpful. So 1 second. Let me go ahead and I'm going to shut that down from running. So PG2 and okay. So just killed it all. So now if I go back into PMM real quick, I should start to see all those connections die off. So let me go back to my Postgres dashboard, and this guy should start to see the CPU. That's the EC2 instance. So let's go to RDS. Yep, it started to die off already. See the number of queries per second drop off. And guessing in a couple seconds the CPU will die off as well. But number of queries has definitely dropped off. All right. So now I should be able to go in here and I go into configuration and I'm going to modify this guy. Right. It's taking its own sweet time. By the way, I don't know if anybody noticed, but AWS was having some issues today. So I did see that there was some downtime there. So we're going to change that to Jobins. And we will continue. And we want to apply this immediately. All right. Now it says it's available, but wonder, were any of those parameters restart required?
Yes, max connections definitely require a restart.
Okay. So I'm wondering if it just didn't show me because I didn't refresh. Oh, there we go. It's modifying now. There we go. So we'll give that a second, and we will watch that off screen. So now let's go into the EC2 instance while we're waiting for that one. Now, obviously, you know, some of the parameters that were set for RDS out of the box aren't going to be set on a default installation of Postgres. So if we go and we look within PMM, when we take a look at this summary again, let's go into the EC2 instance that I've got. We can look at the same settings. This one has a concurrent connection set to 200. I might have changed that. You know, that might have been me changing that. I apologize if I did. But shared buffers is 128 megs. You know, so workspace that's 4 megs. So there's definitely differences.
Yeah. So the max connections is more realistic here. The other one was 1000. The default is 100. Yeah, but the shared memory things we should be adjusting to have 1/4 of the available memory on the system.
Okay. So let me go ahead, and this one we can do old-fashioned shell to change it in the configuration file. So okay.
You can connect and say alter system. That's it.
Oh, you want? Well, yeah, we can do it that way. But then I'm the one who has to type it all, so that's going to be fun.
No problem. I'll guide you. No.
All right. Yes, Jobin's being nice to me. So let's see. So let me go ahead and I'm going to log in real quick, and then I'll show my screen. Okay. So here we are in Matt's magic shell window in the
Okay.
wonderful red, and I'm going to go ahead and I'm going to zoom in a
So-
bit here for this, just so people can see a little easier. All right. What do you
Yeah.
want to do?
How much is available memory in this system?
32 gigs.
32 gigs. So we shall allocate 8 GB for shared buffers.
Okay.
So we can
So
check
walk me, what's the command?
alter system set
Shared buffers?
shared underscore. Just type press tab, it will fill. Yeah. Equal
Oh,
to
will it? Oh, okay. There you go.
in single quotes 8 GB.
Okay.
Yeah. Semicolon enter.
All right.
Yeah. Done.
Okay. What now? What?
Okay. So we are we going to make it same connection as RDS or
We can.
are we
So
Yeah.
alter system set max
underscore connections?
Connection.
Yeah. Equal to
equal to 80. We said right.
yeah.
Does it have to be in single quotes?
No need of single quotes. Yeah. It will take. Yeah. Yeah. And the checkpoints alter system set checkpoint timeout and checkpoint underscore checkpoint underscore timeout equal to
And 1800.
1800.
Okay.
Okay, and the max wall size.
Helps if I type correctly. Anyone who has to live stream and type, it's always a pain, right?
And it was the
All right. And what did we set that to before?
yeah 40 GB. Okay.
Now, what else do we want to look at?
And shall we check the okay, this is easy to instance with the EBS volume, right?
Yes.
Okay, so this also we can modify for the random page cost. So you can check first show random array.
If I spend.
Yeah, semicolon. It's
There.
for yeah, we can modify this alter system.
Okay.
Yeah. So let's give a restart to get all these changes
Okay.
into it. Yeah.
All right.
System CTL, right?
Yeah. Okay. I was going to use service, but
Yeah. Restart.
oh, is it?
System CTL. Yeah. Restart. PostgreSQL. At
What was that? What were you going to have me do?
yeah, if there are multiple instances, we can clearly specify with the at the rate. There is a sub. The system CTL can have sub services.
Yeah, this is just the one. So
Yeah. So you can connect again and check the parameter changes.
okay, and we should be able to do. Yep. And then shared buffers.
Yeah.
Yeah. Okay. So it went ahead and it made them. We checked those. So those are the basic ones that you would recommend we do. Now, let me go ahead and before I kick off the benchmark again, this probably would have failed. Let's see. So this one is the EC2 instance. So let's skip. Let me see if I got still my Python stuff running. I do, but several of them died, so that's cool. Let me go ahead and kill it. And I'm going to go ahead and start that up again so we can get some interesting workload going there. And then let me go back to EC2 and refresh, or the RDS, and let me refresh. So interestingly enough, the RDS instance is still showing modifying. So hard to tell what's going on there. So just
Yeah.
an FYI, so it's still being modified.
Yeah.
So we can't go back and restart the workload on that guy. But let's go ahead and let's take a look at what has happened. If we refresh, we should see those setting changes in PMM now. And so, yep, there are 80 connections. We didn't change the work size, which we did in the RDS size, but okay. So we made some minor changes there. Let's go ahead and let's go back to my favorite dashboard, and let's see what we get here. So before we were running around 1.9 thousand queries a second, or 1900 queries a second. It looks like right now we're running around 2100, so we did get a little bit more. So we'll need some time to verify that actually did bounce up.
Yeah.
But that'll be interesting to see, especially over time, because some of the wall changes there would only work after a heavy write load is when you'd see the difference, right?
Yeah, and as the cache warms up, there could be some changes as well.
Yes, that is true, because since we did bounce, all the cache would get cleared, except for the file system cache.
Yeah.
And our RDS box is still chugging away.
That's one major pain point in RDS. Not just bounce. One of the biggest challenge which customers faces with the RDS is the upgrades. So because
okay.
Yeah. So when so for example, if you want to upgrade from Postgres 12 to 13, even if it is a multi-terabyte Postgres database, if the DBA has shell access, the DBA can just run PG upgrade, which actually does a hard linking between the data directories. So it's instantaneous. Even a multi-terabyte database can be upgraded in seconds or hardly 1 minute, because it's just manipulating the hard links. But we don't have similar option when we deal with the RDS, because we don't have shell access. The only option is to click the button and wait for it.
Right. So I mean, we're already up and running, and we're seeing workload back on the EC2 instance right now, whereas on the RDS instance we're still waiting for the modification to take place. Which is, like I said, taking its sweet time. But yeah, so that's working there. So that wasn't a lot of parameters to change.
Yeah, these are just very basic things, because we know that the RDS uses EBS volume behind, which is a kind of SSD. So we know some of the information in advance. So these are the basic things which we are doing with that advanced information. But we may have to do a lot more tuning once we start understanding the type of workload. So just for example, if we know that what we are going to deal with a OLAP system, okay, we should expect heavy queries, very complex queries, but a number of sessions will be very less. The connections may be very less, but the queries those connections will be firing will be heavy. So we allocate more resources per session. Say, go for more parallelism, parallel execution, parallel queries. What all things we can give to that session, we will give more work mem. So we we shift the resources from other places to the very small set of connections, which is doing a lot of queries, a lot of complex queries. But when if you know that we are going to deal with the OLTP system, we do the reverse. What is important for us is more concurrency. So even I tend to switch off parallel execution.
Really?
Yeah, because when we have parallel execution, few sessions will be consuming a lot of resources in terms of memory. Suppose you have 32 core machine, and few of the sessions are taking say 4 parallelism. So means 4 worker threads per query. So that alone will consume a lot of resources. But at the same time, other sessions will be starving for resources, so the CPU or memory. So when it comes to OLTP system, the preference will be for more concurrency. There could be more large number of sessions, and we need to make sure that the concurrency is handled properly rather than individual query performance or its execution.
Okay. Yeah, and I mean, I think that's where it's interesting. So, there was a little bit of a thing. I saw a blog on DZone where it's like MySQL is faster than Postgres, the other day. And it's funny because for this one particular workload in this really super unscientific test where somebody hit a page load refresh, it's like, look, it's faster. But it's testing, number one, a generic application out of the box with the default configuration basically tests the default configuration for a single like workload that is probably really unrealistic, which is a horrible way to test in and of itself. But there are so many parameters and adjustments that you can make that are very specific to that workload. Now, the workload that I'm using in this test happens to do everything. It's very rare that you have a database that tries to do everything, right?
Yeah.
But it's interesting to see under those circumstances when it is kind of like that everything in the kitchen sink workload. Are there certain things that break or certain things that cause issues? Because each one of the parameters that are out there could, really adjust some of, the throughput that you're seeing based on that workload. And so, if I have a read-only workload, that's very different than a write-heavy workload. A mixed workload is going to be very different than the analytics workload. And so it's hard to make a generic, statement that this is better than this when that workload could change. And a lot of applications, let's be honest, the workload changes potentially from hour to hour.
Yeah. And say, just comparing the performance numbers of databases won't give us any conclusion. That's a same. Just for example, I know the MySQL itself, the old storage engine gives a different performance characteristics than the InnoDB, right? The new one.
Yeah.
And say, forget about all the databases. Even a flat file may give a better performance than all these database engines.
So it's funny. We did a server build challenge like several years ago, and when I was running professional services, we had all the consultants, and I said, "Here's $1,000. Build the fastest machine you can. Benchmark MySQL on it, and we'll see who gets the prize," which happened to be hats with propellers on the top. And somebody put the dev null storage engine, which basically just writes to dev null, right? And so look how fast it is. It's so fast. And I mean, it was the fastest storage engine, but they cheated, so they lost and they didn't get the hat. But there are ways that you can make things like that appear faster, right?
Yeah.
And I think that's one of the interesting challenges. And here's the thing, right? Depending on that workload change, will potentially dictate quite a bit on what you see in your benchmarks.
Yeah, absolutely. I remember you have done a benchmark where the full page writes were switched off. I hope you remember, right?
Okay.
So
Yeah.
the full page writes is a safety mechanism, but there is a big penalty for that. Say after checkpoint, any block which is getting modified will be fully written into the val files. So that results in a huge IO. So
Right.
the Postgres the performance penalty for that full page writes is really heavy, but never we recommend to turn it off, except if there is a fault tolerant file system like ZFS or something like that. Generally we won't tell okay to not so there are other areas like synchronous commit. Okay, so where we can tweak a little bit, and there are specific parameters available in Postgres to tweak many of those areas to get really appealing numbers from the database.
Yeah, I mean, and so this is where it's difficult to sometimes use those generic benchmarks and say like, hey, look at how fast this one is versus this other one. Those tend to give you false results.
Yeah.
Now,
The
interestingly enough, our benchmark or our RDS just finished configuring and updating the configuration 15 minutes later. So I did just start the kitchen sink workload again. And so it is running now. It just hasn't had enough time to do anything. But I can say that so far it looks like on the EC2 instance that we had adjusted, those simple configuration changes, right? Which weren't really, I mean, there weren't that many. There were just a few. You can see here, this is the throughput for those. You can definitely see a pretty, noticeable change in that throughput for the exact same workload, right? So, here, you're in that 1900s and now you're in the 2300s. So, that's it. It's nothing to sneeze at, right? It's something that it's a pretty reasonable. Now, this is fairly, untuned. So, still in terms of like, queries and things like that. But that is an interesting, result. So, when you install things out of the box, even a little bit of tuning can add some substantial benefit in a lot of cases.
Yeah.
Let's take a look at that RDS. So, obviously, here we are down here. And it does look like there was a substantial change in the RDS side as well. Almost over a 25% increase in the throughput, right? For this particular workload.
Yes.
And let's just double check something here. Let me go ahead. And I also, let's do a, let's see. So these are the number of like user functions that were completed per second. So web workload was about 13 a second, and then this is chat workloads at 24. So so those are actually improving as well. So anyway, so those that small amount of changes did make a potentially sizable impact or a noticeable impact, anywhere from 20 to 25 to even 30% in some cases, just by the handful. And I mean, really, what did we change? 6 things?
Yeah. So the one of the assumption was that when we take a RDS instance, everything is pre-tuned and well configured. That's not the case. That's a point which we need to take away. So there are areas where we can further fine tune and get more performance out
Yeah,
of it.
obviously. I mean, here, that again, minor tuning without touching queries. We're just
Yeah.
talking configuration. A 20 to 30% jump, depending on how this workload plays out over the next couple hours. But it was definitely a noticeable change. So thank you, Jobin, for coming. I don't see any questions. If anybody has any questions, comments, things that they want to jump in on, now is the time to throw one our way. We do appreciate you hanging out. Jobin, next time we'll get your screen share to work. So that way, we can have you kind of drive as opposed to me trying to drive based on what you're saying, which is always a difficult position for both of us because you're trying. No, don't do this, don't do that. But I think it worked out pretty well. If you are interested in more content like this, go ahead and subscribe, leave us a comment, tell us, maybe something that we could do better next time. We would appreciate, the feedback. But Jobin, this has been great. And next time we'll try and throw a few more curves your way. I could play Dungeon Master back here where I'll make some adjustments while you're trying to tune the workload. And then you'll be like, what happened? Oh my God. And we'll break things. Maybe I'll crash an instance or something, make you fix it.
Perfect.
All right. All right. Thank you, everybody, for hanging out, and we will see you next time. We're off for a few weeks for Christmas and then and New Year's, so the holidays. So whatever holidays that you guys you folks are all celebrating out there in the YouTube, Twitter, Twitch verse. Appreciate you coming back at the New Year, and we'll see you then.
See you, everyone. Thank you for joining.